So for systems of equations using substitution, this is day 2, so lesson 9-7.4. Again, same thing here. We're just going to have a more variety of types of equations. So substitution is a method of solving a system of equations in which one equation is solved for a variable, and then this expression is plugged into the second equation. Okay, and remembering to put it inside parentheses is always helpful, especially when you have those negative or subtraction symbols in front of it. So step 1, just like our steps in 973, solve one equation for one variable. A lot of times this is already done for you. For step 2, plug the expression from step 1 into the other equation. The second equation should now only have one variable. Step 3, solve the equation from step 2 for that one variable. And in step 4, we'll substitute the value that we obtain in step 3 into the other equation, or it doesn't matter which equation you plug it into, usually the one that's set up to solve for, y. Plug it into that one, and we can then find out what the other variable is, and we can answer our question in ordered pair. So, for example, this one here, this one y is already solved for. It says y equals 7. So just take this value and plug it in for this y. So I'm going to go negative 8x plus 3. Now I'm going to plug it in parentheses, 7 equals 21. Now follow order of operations here. We'll do negative 8x plus 21 equals 21. Now if we subtract 21 on both sides, because we've got to undo addition and subtraction first, we'll bring the negative 8x down. We'll bring our equals down. This is actually 0, and this is going to be 0. Now we divide both sides by negative 8, even though right now you could probably tell what the answer is going to be. This is just how to show the work. We get rid of the negative, get rid of the 8, and x is equal to 0. Now we're not quite done yet. We have half of it done. Now we got to plug in our value. Now you see we don't even have an x value up here, so that makes it really easy. We already know what y is. Okay, we're looking for y. We have x is equal to 0, y is equal to 7. So we just have 0, 7, and that's our solution. So now if we had an x like x plus 7, then we'd have to plug it in, but we don't have that, so we're already done. Okay, now x minus 5y equals 1, negative 2x minus 4y equals negative 16. Now neither of these are solved for a variable. What I want to do is look for the most efficient way on how to solve for a variable. So obviously, the easiest way to do it is solve for one of the variables that do not have a coefficient, like y. We usually like getting in slope-intercept form, but we don't need to. Y actually has a coefficient in front of it, which means that at the end of the problem, we're going to have to divide by something. Look at x. X does not have a coefficient. So what I'm going to do is I'm going to solve for x. So x minus 5y is equal to 1. If I add 5y to both sides, what I'm going to get is x is equal to 5y plus 1. Now, I know what x is. That's all I really needed. So now I'm going to plug in this expression whenever I see x. I'm going to go negative 2 times 5y plus 1 minus 4y is equal to negative 16. Okay, so I don't have to always solve for y. You want to do it the most efficient way. So I could have solved for this y, this x, or this y, but I chose this x because the coefficient was 1. Okay, so the easiest way to do it is to always set it up to solve for the variable with a coefficient of 1. Now, if you don't have a variable with a coefficient of 1, you just have to pick one. It doesn't really matter. All right, now we need to distribute this negative 2, so I'm going to get negative 10y minus 2 minus 4y is equal to negative 16. Now I need to combine like terms, so I'm going to get negative 14y minus 2 is equal to negative 16. I need to add 2 to both sides. Okay, just following my steps of algebra here, so I get negative 14y is equal to negative 14. All right, make a little bit more room for myself. I divide both sides by the coefficient, negative 14. And then I get y is equal to 1. Okay, now that I know what y is, I got to bring it up here and plug it in. Okay, so I'm going to get x is equal to 5 times 1 plus 1, which x then equals 5 plus 1, or just 6. So my answer is going to be 6, 1. Okay? So hopefully that kind of made sense there, why I chose the variable that I chose, just because it's the most efficient way for me to do this. Again, I'm going to choose this x because it's all by itself. Okay, the coefficient is already 1, so I'm going to bring it over here. X minus 5y is equal to 5. I'm going to add 5y to both sides. All right, and I'm going to be left with x is equal to 5y plus 5. All right, so there's my x value. Now I'm going to plug that expression in over here. So I'm going to do 2 times 5y plus 5. Now, why did I do that again? Because x equals this. So if this is x, I'm going to put that expression, this expression right here, in for x. Okay, minus 10y is equal to negative 6. All right, so now I only have one variable left now, so that's great because now I can solve for one variable. All right, so distribute, so I get 10y plus 10 minus 10y equals negative 6. All right, combining like terms here, 10y and negative 10y are going to cancel, so I'm going to be left with 10 equals negative 6. Well, that is not true, so therefore there is no solution. My pen's acting kind of funny right now. No solution, whoops. No solution, and that's because there are parallel lines. Whenever you say no solution, I would like you to explain that they are parallel lines. That just tells me that you are remembering that the only time we can have no solution is when we have parallel lines because they never do cross. Okay. All right, the next one. Again, this is the variable that sticks out to me. This is the one I want to solve for. Since it's on the bottom, I'll just go ahead and work right here. So I'm going to add 6y to both sides. I'll draw my line, and I'm going to get x is equal to 6y minus 20. All right, now I'm going to plug this expression right here, this expression in for x right here. So now I'm going to go with 2 times 6y minus 20 minus 12y is equal to negative 40. All right, now I can distribute my 2. So I'm going to get 12y minus 40 minus 12y equals negative 40. Okay, so what happens now is my 12y and negative 12y, those two things just cancel, and I'm left with negative 40 is equal to negative 40. So therefore, this is true. So therefore, we have infinite solutions. And again, I always like an explanation. Same line. Okay, so even though we're not graphing these things, I still want to know that you are relating these to the graphs. So we're not graphing the parallel lines, but I want you to tell me that they would be parallel lines. You're not graphing this, but I want you to tell me that they are the same line. So if we solve both of these in slope-intercept form, they would be the same equation. But we don't have to do that because we just use the substitution method, and we can figure that out just like this. All right, and that's our last example for 974. So good luck with your worksheet for today.